Dear students, in this video, we will discuss NCERT textbook exercise questions and its solutions. So here we will discuss the questions 6 to 10 from the chapter units and measurement. So before we discuss these questions, if you see this channel first time, kindly like, share and subscribe so that you will get all new notifications. We will go to question number 6. Which of the following is the most precise device for measuring length? There are three options given. A vernier calipers with 20 divisions on the sliding scale, a screw gauge of pitch 1 mm and 100 divisions on the circular scale, an optical instrument that can measure the length to within a wavelength of light. So we will go to option A first. So the least count, the least count of vernier is usually it is one main scale division divided by number of divisions on vernier or the sliding scale. So we will get one main scale division is given as 1 millimeter if we take that one main scale division. And how many divisions are there on the vernier? It is 20. So if we convert 1 millimeter into centimeter, it is 0.1 centimeter divided by 20. That's equal to, you will get 1 by 200 centimeter. So you will get 0.005 centimeter. So this is the least count of the given vernier. Let's go to screw gauge. So here screw gauge is pitch is 1 millimeter and 100 divisions on the circular scale. So what is the least count? Least count is equal to pitch divided by number of divisions on the circular scale. So pitch is equal to 1 millimeter and number of divisions on the circular scale, it is 100. So if you convert 1 millimeter into centimeter, it is 0.1 by 100 centimeter or 1 by 1000 centimeter. So you will get you will get 1 by 1000 centimeter, or that's equal to 0.001 centimeter. So this is the smallest measurement that can be done with the screw gauge. And if we go to option C, an optical instrument that can measure measure length to within a wavelength of light. So wavelength of light is coming usually in the order of 10 to the power minus 7 meter. So you will get 10 to the power minus 5. This one 10 to the power minus 5 centimeter. Okay, so you will get 0.0001. So you will get one more zero here, 0.001 centimeter. Yeah, so the smallest measurement out of these three, if we compare vernier, screw gauge and optical instrument, the smallest measurement is with the optical instrument that can measure the wavelength of length to within a wavelength of light. So 0.001 is the 0.00001 centimeter is the right option. So we will go with the optical instrument. Let us go to question 7. A student measure the thickness of human hair by looking at it through a microscope of magnification 100. He makes here, if we take magnification, that is 100. He makes 20 observations and finds that the average width of the hair in the field of view of the microscope is 3 point. What is the estimate on the thickness of hair? So here what you have to understand, the magnification is given as 100 and here observed width. Is he make 20 observation and find the average width of the hair in the field of view of microscope is 3.5. So you can write observed width is equal to observed width equal to 3.5 mm or 3.5 millimeter, and we have to find out the real width. Okay, so this is a question mark, real width, how much. Okay, so you can take magnification as observed width as A, and observed width if we take it as A, and the actual width if you take it as B. Alright, so we want to find out the actual width or the real width, so that implies B is equal to A by M, so you will get 3.5 millimeter divided by 100, that's equal to 0.035 mm. Okay, so the observed width will be the actual width is 0. The B value is given as 0.035 millimeter. Okay, so this is the actual width, but using this microscope you can see with the width of 3.5 millimeter. Alright, I hope you understand. We'll go to question number 8. You are given a thread and a meter scale. How will you estimate the diameter of the thread? You know, the thread is very small, and it is very difficult to measure the width of the thread or the diameter of the thread with the meter scale. So what you can do is, you can if we have the meter scale like this, okay, so you can bind the thread and you can measure what is this distance, how much is distance, and you count the number of turns here, and the diameter, diameter of the thread is equal to, you can write, suppose if you take it as this length, you take it as x, and and if there are for example, if there are n turns on this much length, so you can measure diameter as x by n. So that's how you will measure. So it is difficult to measure the diameter of the thread with the meter scale. So what you will do, you will bind it for a particular length and you will count how many turns are there and what is the distance covered. So diameter is equal to x by n, where x is the distance covered and n is the number of turns. So that's how we will find out the diameter of the thread. Alright, we will go to question number 8, B's part. A screw gauge has a pitch of 1 millimeter. So here given pitch is equal to 1 millimeter, and number of divisions on the circular scale, it is 200. Do you think it is possible to increase the accuracy of the screw gauge arbitrarily by increasing the number of divisions on the circular scale? So if we speak theoretically, you know, the least count, it will decrease with increasing the number of divisions on the least count. Decreases with more divisions on circular scale. This is the point, more divisions on the circular scale. So that's what happens. But it is not possible to increase the number of divisions on the circular scale, because there is a limit for the human eye, resolution of the human eye. There is a limit for the human eye, so it is not that much easy to increase the number of divisions on the circular scale. Okay, so theoretically it is correct. So the least count decreases with more divisions on the circular scale. But practically it is difficult. Alright, we will go to question number 8 only, C part. The mean diameter of a thin brass rod is to be measured by vernier calipers. Y is a set of 100 measurements of the diameter is expected to yield more reliable estimate than a set of 5 measurements. Okay, so whenever you do a measurement, we will take we will do 5 or 6 trials, or we will take that so many measurements. Whenever you do any measurement with vernier or screw gauge, you will do more measurement. So here they are saying 100 measurements of the diameter expected to yield a more reliable estimate than. So whenever you do the experiment in the lab, usually you will do 5 or 6, but here they say 100 measurements. If you do, it will give you better result. Alright, so this is because the possibility of making a positive random error of certain magnitude is equal to that of making negative random error of the same magnitude. Out of 100, maybe if you do 100 measurement, 50 will make a positive random error and 50 will make a negative random error. So what you can do, these both will be cancelled out, you will get a better result. Okay, so what is the reason they suggest 100 measurements? Because the random errors will be cancelled out. Random errors will be cancelled out, so you will get a better result. Random error, that is how that's why they suggest 100 measurements, and the result will be more reliable. All right, so we will go to question number 9. The photograph of a house occupies an area of 1.75 centimeter square on a 35 millimeter slide. The width the slide is projected onto a screen, and the area of the house on the screen is 1.55 meter square. What is the linear magnification of the projector screen arrangement? So here, area of the object is area of, if we say area of object given as area of object is equal to 1.75. area of object is 1.75 centimeter square, and if you take the area of image is area of image is 1.55 meter square. All right, so here both you can this is 1 centimeter square, and here you can change into the meter square, so it is meter. If you convert into centimeter, it's 100, so 1.55 into 10 raised to 4 centimeter square. Right, so aerial magnification is equal to so first we will go with the aerial magnification. Aerial magnification is equal to aerial magnification, of course, area of the image by area of object. Area of image by area of object, yeah, or area of object, area of image divided by area of object. So you will get area of image 1.55 into 10 raised to 4 divided by 1.75, so you will get 8857. Yes, and also this is the aerial magnification. So you know that square root of area is equal to length into length. So usually linear magnification, you will consider as linear magnification as root of 8857. So root of 8857, that will give you the result around 94. So this is what the linear magnification. So when you do the calculation, you will get the, when you find out the root of 8857, 8857, you will get the magnification as 94. Alright. So we will go to the question number 10. Question number 10 in this state the number of significant figures in the following. So we will discuss all the options here. Option A. If you study the rules of the significant figures here, 0.007 meter square, so that you can write it as 7 into 10 to the power minus 3, 7 into 10 to the power minus 3 meter square, 7 into 10 to the power minus 3 meter square. So 7 into 10 to the power minus 3 meter square. So the number of significant figures here, it is 1. So the number of significant figures here, it is 1. And now question number B, you will get 2.64 into 10 to the power 24 kg. Again, this one we are not considering. So the number of significant figures here, it is 3. And question number 10, option C here, and C part, it is this one, 0.2370 gram per centimeter cube. So here you will get 0.2370 gram per. So we are not considering this 0 here. So we have only these 3 parts we have to consider. So again, the number of significant figures is 3. Then option D, 6.320 joule, 6.320 joule. So here option D, here it is here 6.320. okay, so we have to consider this, to include this 0 also. So the number of significant figures, it is 4. In the same way here, after this decimal point we have 0 here, so sorry, we have to include this 0 also. So the number of significant figures will be 4 here. Okay, and here 6.320, it is joule, and the number of significant figures 4 here. And here D is go over, D it is 4. And E, this question E, we will, if you consider E, okay, so here it is E part 6.03. E again, you know that it is 6.032 Newton per meter square. Again, it is number of significant figures, it is 4. We will include all this one. And the last question, F is equal to 6.032 into 10 to the power, how many you can write? -1, -2, -3, -4. You can write it as like this, 10 to the power -4. So here it is 32. So again, the number of significant figures is equal to 4. So once again, I'll explain the number of significant figures here. The question number 1 here, 0.007 meter, that you can write it as 7 into 10 to the power -3. So 10 to the power we won't consider, only this one. So the number of significant figures is 1. And 2.64 into 10 to the power 24 kg, again number of significant figures 3. And 0.2370 grams centimeter cube. So after decimal point, this 0 comes, means it is valid. So the number of significant figures, it is 4. And 6.320. So here the number of significant figures, it is coming 6320. So all these are counted. So number of significant 4. and 6.032, again it is 4, and 6.032 into 10 to the power minus 4. That means the last question, again the number of significant figures it is more. So here we discussed the questions from questions number 6 to 10. I hope you understand all these questions. So if you like this channel, kindly subscribe it so that you will get the new notification. In another video we will explain the remaining questions. Thank you.